First of all, this is a 2.5-inch gauge. It's what's known as a Class B or Class 2 gauge. And it's broken into two parts: pressure and vacuum. Okay, so negative pressure, if you will. The challenge with this gauge is that the refrigerants and the pressures and the temperatures that we were dealing with once upon a time were fairly simplistic. And so the accuracy of the gauge being the first third being 3%, the middle third being 2%, and the top being 3% accurate was acceptable, and it worked for the industry. But then when they bought out some new refrigerants a number of years ago that were higher pressures, the industry asked for a gauge, this gauge, that would accommodate the higher pressure systems. And that wasn't practical. So they came up with a new gauge, which is 3 1/8 inches in diameter. And it has a different type of gear assembly in the back end than does the original. The net result being that this gauge is factually 1% accurate full scale. So that was a big bonus. Okay. Now, what we're looking at here is this is the negative side, and so this is where we're talking about evacuating a system. The system normally runs at some kind of pressure up here. We're coming down to 0, and we're going to pull it down into a vacuum itself. And these are inches of vacuum, so 0 to 30 inches of vacuum. And that's inches. So then we want to look at this, and we want to break it down even more. We have to look at it in terms of microns, and a micron is nothing more than a unit of measure, yards, feet, inches. That's all been taken, so microns is the word. So if we look at this gauge and we go from 0 down to 30 inches or 29.92 inches of vacuum, there are factually 760,000 microns there. So that's a lot to look at. It's a big number. So we take that next step down and we talk about the difference between this mark here, 29, and this mark here, 30. There's actually 25,400 microns in that 1 inch. If we break that 1 inch in half, again, it's down to 12,700. Break it in half again, 1/4 inch, it's 6,350. We break it down to 1/8 of an inch, 3,175. We come down to a 1/16 of an inch, 1,587.5. A 32nd of an inch, 793.75. And finally, down to a 64th of this mark, this last mark between 29 and 30, for 396.8 microns. Why is this all important? You need a gauge that has the capacity to read these numbers, not like this, because you're not removing non-condensables from a system until you reach at least 5,000 microns. And you can't read that on that gauge. You can have a leak in a system, okay, that's so small you are evacuating, but you're also, the leak is so small it's pulling air in, so you're really just transferring from one to another. You're not actually evacuating the system. It's impossible to evacuate that system. You could never tell that with this gauge. This type of a gauge with this kind of a reading, it does allow you to have that in that type of information, the detail of the information, if you will. So the micron gauge, critical when you're evacuating a system. If you own a vacuum pump, you really should be compelled to own a micron gauge and understand exactly what it is and why it does what it does. There are a variety of different micron gauges out there, and we make them all available. Some have little lights on it. When you get down to a certain level, a light comes on or a light goes out, whatever the case may be. Some of the gauges don't read until you get down in here somewhere. We have a gauge that only reads the last inch the 25,400 microns. So there's a lot going on between 25,400 and 760,000. Okay, nice to know what that is. With the right kind of a gauge, you can read it. With the wrong gauge, of course, you're just guessing. So that's what micron gauges are all about. Why they're so important. So with this device, okay, there's a fudge factor built into it, and if the light came on or went out, whatever it is, at for argument's sake 1500, that would mean that the actual is anywhere from 1001 through 1999. So it's a guesstimate of scale. The really of little value. This fellow, okay, it has a reading of 25,000 microns, so we're only dealing with the last inch. And there's a lot going on between 760,000 and 25,000 microns. Next point, okay, that's critical, that a lot of people don't appreciate the importance of this. It's a man thing, I know, but I always tell people, keep it up. Okay? Very, very important. Oil will not migrate uphill into the sensor body. If you mount it this, oil will run down, it will contaminate the sensor and give you a false reading. Very, very important that you mount it properly. So 25,000 microns, and then the tool, the 69075 which reads fully, it's too bad there wasn't a battery in there, which reads fully 760,000 microns. Again, it's an issue of making sure that you mount it in an upright position. Do not, under any circumstances, mount it this way. Okay? You will end up buying a new sensor. Be aware.